Okay, well, apparently I don't know how to pause. So we're on video part 2 now. I accidentally stopped instead of paused, which made it process the video. I'm kind of glad that I did though, because the next couple of problems are a little trickier. Tangent of pi, we don't talk a lot about the tangents of the quadrantals. If you know our ordered pair quadrantals, oops, the quadrantals are our ordered pair. Our tangents are, remember, y over x. So at pi and at 0, my tangents are 0. At pi over 2 and 3 pi over 2, my tangents are undefined. So really there's only two tangents you kind of have to know for quadrantals, either the horizontals, where tangents are 0, or the verticals, where the tangent is undefined. So the tangent of pi is 0. 0 is tricky because 0 radians as an angle and 0 as a value all look the same. So you always have to kind of remind yourself what you're thinking. The inverse sine of 0, that's the angle that has a sine of 0. Restricted value. 0 has a sine of 0. So does pi. So does 2 pi. But remember, if we're doing inverse sine, our answer has to be between negative pi over 2 and pi over 2. So the angle that has a sine of 0 is 0. When we start going outside of into other quadrants, you might first think, oh, you can't. But you can when you're just doing the value part. Cosine of 5 pi over 6, I can do a cosine or a sine in any quadrant. If I'm doing an arc cosine or an arc sine or an arc tangent, I have restrictions. But just a cosine or a sine or a tangent, I can go in any quadrant. Cosine 5 pi over 6, pi over 6 family, cosine value, negative root 3 over 2. And I'm going to make a little asterisk by this because if I'm doing an inverse of a negative, that means alternate quadrant. It's usually quadrant 1 and then the other quadrant. In sine and tan, it's quadrants 1 and 4. In inverse sine, it's quadrants 1 and 2. Since the arc part is an arc sine, I'm going to go quadrants 1 and 4. So I need the sine of root 3 over 2. So that's the big sine, or the big Y, in quadrant 4. Negative pi over 3. Now, if you wanted to pause now, I'm not going to try to pause because apparently I figured out I can't do that. I'm bad at pausing. Negative pi over 6, sine of negative pi over 6 is negative 1/2. Inverse cosine negative 1/2 star, we're going to be in the alternate quadrant. Remember, alternate quadrant for cosine, arc cosine is quadrant 2. Little cosine, so over just a little bit. That's going to be 2 pi over 3. And then number 7, my favorite problem. Arc sine of sine. Arc sine of sine, arc cosine of cosine, arc tan of tan. We love that. These guys are inverses. When you take the sine of an angle, okay, sine of pi over 6, and you get 1/2, and I ask you, all right, now go back to the angle, arc sine of a half, we're going to go right back to pi over 6. We just undo each other. It's a great shortcut that works. For example, arc cosine of cosine of pi over 3, pi over 3. But that's only going to work really nicely if you're working in quadrant 1. If you're in another quadrant, you're going to potentially start bringing in negatives. and it's going to change how you have to talk about the problem. For example, this arcsine of sine of 2/3, if I follow the rules, this would be the arcsine of the sine of 2 pi over 3. Okay, and the sine of 2 pi over 3 is root 3 over 2. When I answer this question, I have to give a quadrant 1 answer. Inverse sines come out of quadrants 1 and 4. That's so they act as functions, so they only have one answer. So the inverse sine of root 3 over 2 is pi over 3. Why isn't it 2 pi over 3? It's not in the right quadrant to use inverse sine. Okay. So this is one type of inverse problem. Inverse problem where we have the inverse trig on the outside. We can also have the inverse trig on the inside. Same approach though. We are still going to go inside out. But what you have to remember when you're doing inverse trig first, you're going to be getting angle information first, and you're going to be operating under restrictions. So you have to make sure you pull the correct angle based on the restrictions. Inverse cosine of a half. Quadrant 1. Where is my cosine a half? Cosine is x. Cosine is a half at pi over 3. The sine of pi over 3, root 3 over 2. Oftentimes, we can look at this and go, oh, look, it's the angle. I want to go to a certain angle, has a certain cosine, but then I want its sine. So it's not super surprising that this is a half, but then this got to root 3 over 2. It's kind of like I'm looking for the other number in their partnership. Sometimes you can get to things that aren't 100% related, though, or not as easily related. Tangents are always tougher to hunt down. The one with the lot of 3's is the pi over 6 one. Double 3's is the pi over 6. And then cosine of pi over 6. 3 over 2. There are only so many answers. If we're going to work with unit circles, there's only so many answers we can give for sine values, for cosine values, for tangent values. They all sort of fall in the same category of, our sines are a half, square root of 2 over 2, square root of 3 over 2. Zeros, ones, and negative ones. Same thing for our cosines. Our tangent values are 0, 1, root 3 over 3, root 3, undefined. Okay, because we're restricting ourselves to the unit circle, we only have so many numbers that we can potentially talk about. Quadrantals. always going to be a little trickier for, at least for me. I always have to go, wait a minute. And so -1, ones and -1s for sines and cosines start me thinking quadrantals. Inverse sine of -1 is -pi/2. And tangent of -pi/2 is undefined. Once again, if I'm looking for where is my sine equal to -1, that's down here, but based on my restrictions, I've got to call this -pi/2. When I'm down here, whether I call it 3pi/2 or -pi/2, I do have that undefined tangent. Lost track of where my pages are. And then, once again, if we've got a nice combination of functions here, arc cosine of cosine, if I just kind of think through and I'm like, well, the arc cosine of √2/2 is pi/4. And then, well, what's the cosine of pi/4? √2/2. Once again, we've got this little inverse pair combo that works. And this actually works super great. Whether this is positive or negative, you can attack the problem. These two will undo each other perfectly. Cosine of an inverse cosine, sine of an inverse sine, tan of an inverse tan always undo each other. So worksheet 2 is going to have a bunch of practice for these on there. You're also going to have a Schoology assignment to practice both the regular inverse trig problems and a couple composition problems. So those are your 2 assignments. And that's my dog playing with his squeaky toy. You get to hear in the background. Hope everybody is doing well, and I will hope to see you in school on Monday. Thanks, guys.